broadcasting live from the London Java community. I'm going to do a quick session on Clojure and Clojure with data. Just a quick intro to why you would do Clojure. It's mainly Java developers, so we're going to just briefly cover that. So Java is a great language. It's even better kind of JVM. It's like so many years and years of really good design has been put into Clojure, into JVM. And so one of the reasons to build a new language on top of the JVM was because of all that excellent work there and all the libraries you can get, all the open source stuff you can get with Java. You can build things really, really quickly and easily. So it doesn't make sense to create a new runtime that doesn't have access to that. So Clojure is very much a hosted language. So you can run it on, so it started in the Java world, but you can also host it on JavaScript. You can do it in Go. You can use Graal VM as well to run things, native images. So one of my colleagues is while they're doing the cups and things. And so so there's that aspect. So so he's building another language on the JVM because not everybody is happy with some of the constraints around Java. It's an OO programming language, whereas Clojure is a functional programming language. And so, yes, there is Scala. There are other languages as well. I think there's even Haskell J or something like that. There's also so you can pretty much run. There's lots of different languages. Frege, yes, thank you very much. Well, there was a Haskell J ages ago. Yeah. Frege is another one.
If you can get it to compile, I last time tried it, kind of failed. But if you try to get it compiled, then you can.
Yeah. So Frege is another really nice language as well. You can use, and so there's quite a few languages on there. So Clojure's been around for about 11 years, and the idea was to do several things. Is to bring in a language that was really good at concurrency. Does anybody love doing concurrency in Java?
Yeah.
Nobody.
No, I said yes.
Yes, nobody honestly is saying that. I mean, it is challenging. You can do it. Obviously, it's very powerful. Yeah, it's very powerful, but it is challenging as well.
It is.
And one of the challenges with Java, obviously, is like designing a big, designing an object hierarchy, designing all your types and things like that, and managing when things change as well. So it's not necessarily Java has some constraints about how quickly you change the design of things as well. Whereas functional programming and dynamically typed languages are a lot more flexible in terms of kind of evolving a design really, really quickly, because you don't have the overhead of designing like a type hierarchy. You don't have to worry about types. You can come to that later if you want. If you can like hammer down types and do a lot of type hinting in Clojure, but you don't have to have that initial kind of thought about what your type structure and your type hierarchy actually is. And obviously, the functional approach is very different as well. And Clojure doesn't take a pure functional approach like Haskell does. It takes a more pragmatic approach. So it encourages you to have pure functions, and a pure function is basically something that only gets its information from its arguments and only returns a value. It doesn't affect anything else in the system. And if you've got all your functions, which will be methods in Java, and they only do what is given to them and return a value, then you can actually understand the system very, very easily, because you can just look at it in pieces. And if you understand all the pieces, then you can see how those pieces work together, and you can understand a much more complex system just by understanding very, very simple things. I think that's me in my head.
So there's this thing called, what's the term in Scala? I learned transitivity. Do you know that?
Transitivity?
Yeah. So, when you're talking about no side effects, there are these principles that a pure function should abide. And one of them is that if you repeatedly give it the same input, it should always give you the same output.
Yeah, it's kind of like that, I guess. Yeah. So with iterative programming, you've got kind of a flow to things, and with Clojure, it's kind of like you're combining functions together, and those functions can be arguments to other functions and so on. So you can start off with one like your main function that calls another function, which takes an argument, and so on and so on. And if all these are fairly independent, then it's very easy to see what each of these do. So your main function isn't that complex, because you can decompose exactly what it does in terms of small functions there as well. I don't think I'm sharing that screen. Actually, I'm going to share the screen. for seconds.
So,
screen share. I'm just going to share my entire one. Yeah, it does that. Look at that. That's fancy. That's why it's going to go away. There we go. So there is this idea of like thinking functionally. So this all is on the web. My practically Clojure book. But you've got things like side effects. So you can think of it as like a pure function is this green path. So you've got arguments coming in, function, which is your behavior, and then you have a return value. And that might be a simple value, or it might be a complex value you return. It might be a collection of some things, or it might just be a simple string or numbers. And that's pure along the green line. If you're pulling values like from shared information, so you're pulling from a database, you're no longer pure because anything could be in the database. You don't know what that information is going to be, and somebody might change that information in between. So another thread might change it before you actually get there. And if you're doing things to the other side, if you're doing like if you've got lots of setters in Java, and you've got lots of things that can set the setters, how do you know when your object is going to change? You have to know a lot more about your application in order to know just what that one function does, because it's pulling information in from all sorts of other places as well.
Which book is this? Is it practically?
Practically Clojure one, okay. Yes. I'll put the links in the end of there, but yeah, it's practically.github.io. Okay, so that's just a very quick overview of like why Clojure, really, and also it's what we're going to show you is my editor. I'm just going to make this a bit bigger, and we're just going to walk through some code, and I'm going to do so. So this is not just going to be the code of the text of my code. I'm actually going to attach this to a REPL. So I'm going to do that now while I'm talking. So I'm just going to do cider jack-in, which basically starts a Clojure environment called the REPL, which is read, evaluate, print, and loop. And that's essentially how Clojure works. So Clojure reads in the code, it evaluates it, prints out a result from that evaluation, and then loops back to whatever the next thing it needs to do. Did you have a question?
Yeah, it's all part of the standard distribution.
Yes. So you can get Clojure now as just like command line tools, and like normally you would use a build tool, like a Maven-like build tool, but without having to define everything in XML. In fact, you can define your project in Clojure itself.
Line does a good job of giving you a ready-to-use project, doesn't it?
Yeah.
Is this Emacs?
This is Emacs, yes. Although you don't have to use Emacs. that is so. I mean, this is just a project configuration file for Clojure.
How important is it to learn Emacs?
Not at all. Well, in terms of doing Clojure, you don't need to learn Emacs whatsoever. I think as a way of life, as a life decision.
It's a life decision.
I think it could be quite important, depending on the kind of life.
Life decision or lifestyle decision?
It possibly is more than yes, it might be connotations of religion as well. But it's a bit of a cult. It's a very positive cult if it is. But it is yeah, about half of the developers who use Clojure use some form of Emacs. Some use Vim, but then there's IntelliJ as well. It's got really good support. If you're used to using IntelliJ, then use IntelliJ. There's no need to move over to Emacs just for Clojure, but I'm happy to convert you over to Emacs should you wish to.
So
anyway.
there's a cursive plugin available in IntelliJ that you could use. But I don't know, they have made it such that in the paid version of IntelliJ, if you use the plugin version of cursive, then it says, oh, your subscription has expired. So you could only use the non-paid version of cursive in the community version of IntelliJ, and that works fine.
Or you can just buy the plugin. So it's only $99. So I'll get your company to buy it. It's really good. So.
I know you're probably going to explain, but why are the line numbers quotes?
Oh yeah, that's my. So line numbers are relative, so I can jump if I wanted to go to the fourth line down. I can pretty easily do that.
And you can only jump like how many? You can jump up to.
Yeah. Well, obviously I can't jump more than 6
because you're like 6 lines, but you had like 100 lines.
Yeah. If I got a longer one, I can jump around. So in terms of defining Clojure, we've just got this. Well, in fact, this is a data structure. This is a piece of code, but it's a data structure. So the round brackets mean it's a list, and that's a linked list. in, well, pretty much any language. So the first element points to the next element in the list, and so on and so on. So it's quite efficient to add things to the front of a list. It's not so efficient to add things to the back of the list. And so this is a list. So we've got a first thing in a list is going to be a function call. So we've got a function called def project, which allows us to define our project, and everything else here is just an argument to that function. And so all our projects, we can just write Clojure essentially to define all the projects, so we don't have to learn anything else. And the dependencies are just a data structure. Here we've got a vector of vectors. So it's a vector is just like an array, although it's kind of fixed when you create it because it's an immutable array. So, but that means you don't have to kind of worry about expanding it and contracting it. You would just, if you wanted to modify this array because it's immutable, you just take a copy, and the new one will be the size of whatever elements you want to put into that array. And so it's a vector of vectors because like each dependency is kind of like the Maven style of dependencies. So you've got the name, you've got the version number, the semantic versioning of the version, and we've got multiple of them. So we put that in a vector. The vector is kind of the simplest possible data structure you can have in Clojure that for data only. And it's an indexed data structure as well. So it's indexed just like an array. So let's go through some examples. How are we doing? Oh, we've got 35 minutes.
Really?
Yes, really. Let's start. Is that text big enough for everybody? Yes. Okay. Yeah. Okay, cool. So I'm just going to do some brief kind of really gentle stuff. This is talking about how you design, instead of designing objects, you tend to design data structures. And then you write methods, functions on those that manipulate those data structures. And that's the design of Clojure, essentially, in a nutshell. So here we've got a map. It's like a dictionary. It's a hash map, essentially. So I've got title, which is a key, and the string that title is associated with is its value. So we've got key value pairs, and we have to, it enforces key value pairs. So there has to be a key value pair. There can be more than one. There can be none, so you can have an empty map as well, which is just the empty map, and this evaluates correctly as well. Let's just check that it's all working. An empty map will evaluate to an empty map, and so a map with stuff in will evaluate to a map with stuff in. So it evaluates itself. So in a way, kind of a map is acting like a function. It will tell you what's inside it when you evaluate it. And rather than typing out all this information all the time, we can give a name to this information. So we can create, we can use this def function for define, and we give it a name. Let's call it blog post, and then we can assign that name to any kind of value. Here we're doing it to a map. We could do it to a single value, like a number or an integer or a float, or we could assign it to a string or a function. In this case, we're just defining a name for a map, or a nested map in this case.
Could I ask one?
Yeah, sure.
Is the map actually map, or is it a persistent map?
Yeah, so underneath this, from the developer's point of view, you're creating a map, which is just a name value pair. It's just a bit like JSON, and so if you were receiving JSON stuff in a natural format to put it into, would be a map. But underneath, it's implemented as if we do this as we can actually go in. Although we're not defining any types here, the types are all kind of implicit. So when Clojure reads these things, it decides on what the map on what the types are. So here we've got in the map, it's got a title, which is a keyword, and then a string. The string's denoted by double quotes. But if I do a type here, and I'm just going to slurp this in, so it's inside. So we're going to call this function called type, which is the first element in the list, and its argument is going to be the whole map. So what's the type of the whole map? And we can go in and evaluate that. It's this Clojure lang persistent array map. And that means it's an immutable data structure, so I can't actually change this. And then you think, well, what's the point of having some data if you can't change it? Well, the idea is you don't change it, you create a new copy. Then you say, well, that's a hideously inefficient way of doing things. But then you've got a persistent array map, which is designed to do very optimal copying of data structures. And so I think I had a
You're basically keeping the garbage collector companies in business, aren't you?
Well, I think
garbage collector writers.
I think Java does that quite nicely all by itself.
Well, wait till the ZGC is out and the other one.
Yeah, so there is scope for garbage collection, but what Clojure does when you create a new data structure is it copies it doesn't copy everything that's the same. It will actually only create new parts of things if they're different. So here we've got if we have a persistent data structure that contains the values, the numbers 1, 2, 3, 4, 5, and we go in and add 6, we're actually only creating a new collection that contains 6, and everything else is a pointer to the previous version.
So
it's like a diff.
Inefficient though, the managing those?
No, it's insanely efficient.
Okay, so if you insert stuff in between those, you can't insert, right?
So you don't insert anything; you just create a new copy, and then every time you want to change something, you create a new copy. And if anything is the same as the previous one, you just reuse that as well.
So then it's not going to get garbage collected because they're linked with.
Exactly. Yeah. So you won't get garbage collected until you create a brand new collection that's got nothing to do with the previous one. And yeah, exactly. So it's a very efficient way. I think it only came up with, there was a technique that somebody came up with like about 15 years ago, and then they realized they could kind of do that because they realized how to do that with mutable data structures first. So like Scala uses this for mutable data structures, and then there's a refinement so we could do this efficiently for immutable data structures as well. There's a whole bunch of stuff on this Polymathia link as well, which goes into it in far more detail than I've got time to. But yeah, it's
this it's fine as well.
yeah, kind of. I mean, there was to do it in general for all the different data collections. That was the thing that came about 15 years ago.
I guess list basically just a list, really.
Well, list, but just had linked lists really. So it was purposely quite simple. And originally it was a bit slow, but because we're using the functionality and the features of the JVM, it does make it an awful lot faster as well. Where do we get to? Let's go back to Emacs. Okay, so we can see the types. So we don't need to define types, but we can see the types underneath. So if you actually go in and we can also go in and look at this. What do you think the type of a string would be?
Persistent.
Yeah. So are there any kind of characteristics of a string in Java that make it feel like it's like Clojure? What do we know about a string in Java?
It's a collection of array.
A string it's immutable in Java, so therefore we can use it. We can use because we can use it very comfortably from there. So we didn't need to write something that was immutable on top of Java lang string because we just use it. If you're on other platforms, if you're doing Clojure for JavaScript, then there are other ways around that to make the most out of that host platform.
It's a very good comment.
Yeah, sure.
The string has special support in the JVM, don't they? Because they actually get their own special area where
string pool, but that's only since a certain version of Java, right?
Yeah, but I mean, obviously, all the modern versions of Java have that. So, is that kind of idea going to get generalized for other sort of data types that be immutable? So there are pools of different things, and
No, I think that's only known for the string world, not for.
Yeah, the way that persistence works is pretty uniform in Clojure, and it's quite shallow. So you've got very broad kind of data structures. Each node is about 32 bits long, and then you've got like a really flat structure to do that. That's how they kind of do it efficiently. But yeah, I don't think there isn't really similarities in Java, except where we just use the Java types themselves. Let's see what I'm doing. Oh.
You still have 35 minutes left, right, John?
I have 28 minutes left. There we go. Okay. So let's. My clock is immutable, yes.
In Clojure, right? So it doesn't change. More time can come. You say, yeah, it's still the same time.
Well, it is lunchtime after this, so it depends how desperate you are for food. So I purposely did this for lunchtime. So if I overrun, then people just leave if they were hungry and not if they weren't. So. Yeah.
Dedication.
Oh, dedication. I'll be here all through. I had like 3 breakfasts, so I'm fine.
3 breakfasts.
Well, it was.
That's why all the food was missing. And
No. Well, they didn't put enough vegetarian food on, but there we go.
No, there was.
Oh, great.
No.
It's a fruit I couldn't find it.
Yeah.
But okay, let's cut back to Clojure for a moment. And so yeah, so I've created. So I've taken a map and I've given it a name using this def function. So I can refer to the whole map as blog post. And I can go in and get values from that map as well. So here I'm just grabbing the title. So I go in, I say, get from this map the value that title points to, and so then it'll pull it out for me. And it's a nested map, so the author actually has got several parts to the value. So the author value itself is a map. So we can have maps within maps. This is very common in Clojure. And so I would need to kind of walk the tree. I would need to kind of walk through author name to get to John Stevenson. So I could do, I could do a get around a get, because this get would return like a map here. Let's see. So this one returns a string here. If I do a get blog, if I just do this by itself, I think it's there. Let's see. Then that's just returning the title. Oh, actually, that's not what I wanted to do, is it? No. Yeah. So let's call that the name. Yes, you can see I wrote this last night very quickly. There we go. And then yeah, author. So this one is going to return a map, and then from that map we want to then pull out some more information. So rather than do that, it's a bit long-worded. It's not particularly elegant. We've also got this get-in function, which is a refinement around get. Oops. And we can get in the blog post where the value is found by going to author and then name, and then it returns a value for me as well. So we can walk the tree. So it's a bit like XPath and other things like that.
Is that a post and posts?
Post.
Oh yes.
Yeah, post
You see, I refactored it and I wasn't paying attention. When
Well,
I was
the
doing
ID is telling you that.
it was. I wasn't paying attention to the ID. There we go.
One more breakfast. John.
Yeah, too many breakfasts.
Or do you want some coffee?
No, I'm okay. I don't do well with coffee. And so it allows me to pull out the right kind of name, the right kind of value from that. So it's very easy to get information out. Walk a very complex nested tree very easily. And we use these.
So if let's say name has got first name and last name,
Yeah.
you just have to put another one that says whatever the one you want.
Well,
As a third item in a.
Yeah.
You just do like a directory. You do A/B/D. That's the same thing.
Same thing. Yeah. So
Yeah.
it could be author name and last name.
Yeah.
So if I split this up into I could do this. So name could be made up of first, and then like a value, and then last a value as well.
One thing I disagree with the title, meaningful data. Not so meaningful in that.
I haven't really got very meaningful. Again, that's something to work on. It's driving.
You can't change much about yourself, right? You're immutable.
Well, I change myself all the time. I'm not that immutable. I mean, there's certain things that are seem to be immutable. Certain things I wish weren't immutable, like this. And
So with these maps and data structures, it's possible to change the underlying data structure.
So can we change the underlying data structure of the maps? You can transform them. I mean, pretty much what you're doing. I mean, here what I'm essentially doing is transforming with this command or this command, transforming that data structure into a string. I'm just kind of, okay, I just want that string. That's my data now. So my data has gone from being a map to just the piece of the data from that map that I actually wanted. And it's a new version, but for me, that's the bit that I'm interested in. So in a way, you could see this as map reduced, but just being very specifically getting out the kind of information you wanted. But yeah, so we kind of do a lot of transformation about, here's our overall map or our overall data structure, which might be maps and vectors or some combination. Could even be sets and so on, strings. So we can join whatever kind of values we want together. And I put this, I mean, we could even have instead of GitHub, we could actually have like a function that we could call that would go off and actually go off and get, so get GitHub account details with JRocket.
You have that function ready, or just going to write it?
We could write it if you want, but I might take more time than I've got. So I shall leave that to your imagination, or for homework, or for tomorrow if I get around to it. So,
what time is tomorrow?
If we go tomorrow, will be at the same time, 11 o'clock in the morning on Sunday.
Oh, I'll still be in bed.
Yeah, I might still be in bed as well. But if you don't see the web,
he's just going to run his video that he recorded the previous night.
If you don't see me on the video cam, if I switch my video cam off, it means I'm still in bed doing the broadcast. That's fine. It's the closure that matters, not my kind of particular
So I noticed
state.
that sorry to get more. What if you had multiple authors there and you had a vector of maps?
Yeah. You sure you can do it? Yeah.
So second element, and out of that, how would you specify that?
Yeah, so if I wanted a kind of a blog website kind of thing, then which was made up of different blog posts, then yeah, a very simple data structure is the vector, which is just an array. What I'm doing? Oh, it's.
I can see John is also being like Clojure. He's copying stuff into new places. It's not over.
I am, yes, indeed, yes. And then let's do. I missed that.
Actually, he meant if there were multiple authors on the title itself.
Oh, did you?
So you had one key, like author is a key, and if you had a list of things rather than actually a map.
Yeah. So I mean, here I'm kind of doing like multiple blog posts, but yes, you could have author. So author is. Let's go back to the simpler version. So author, instead of being one, we can insert a vector, and we can slurp that in. Slurp. So slurping is where you pull a one expression into another expression, so structured editing. And if I kill that and undo that and paste on, oops, didn't want to do that. There we go. Oops. Paste that in there. Yeah, so I can have multiple kind of authors, and then I would
put a comma next to like
the commas in Clojure are just white space. I mean, I could put a comma in for the developer, but the developer usually gets used to not having commas there eventually, anyway, because it's just one extra character you don't need to type in. Yeah, I mean,
it's interesting how the author will be, or you'll do the get.
We call the second author Stephen Johnson.
It'll return the whole vector, isn't it?
Oh yeah. So
getting won't work anymore because
Stephen Johnson.
Stephen Johnson, yes. They might alter ego here.
Imaginary Jane, yeah. Jane.
I wonder if that's actually available or not. Yeah, so there is a slight difference in how I would extract it, but I would start off by getting the same kind of thing. So here we still have the blog post, so we still do get from blog post. And I didn't actually evaluate that, so I'll reevaluate. So the nice thing about the REPL is I'm involving the definition of what blog post is. So whether this is a function or just a name I'm doing. I can reload into the runtime environments what that means. So basically redefining it. So blog post in that sense is a var, is a variable. It's something that can change while you're developing it. Obviously, at runtime, you're not going to be messing around with it unless you really want to. I mean, you can connect to a live running REPL if you really want to, but usually you just do that during development time. So did I evaluate that? I did not.
But can you use that feature to patch stuff?
Yeah, you can do live patching of if you've got a website, for example, that you can't bring down for whatever reason, but you need to desperately patch something because you're starting to get hacked. Then you actually connect to the live running REPL that you set up for it, and run that as connect to it and actually inject code into inject definitions, function definitions, name definitions into that as well. So you could change it live.
So you could have a live update, like how JRebels do.
Yeah, you could have a live update of your code base. Is it advisable? Only under extremely necessary situations. So you wouldn't kind of do that as a matter of course.
I know a lot of PHP developers do though.
Possibly, but there are people who do these kind of things, and if they're willing to accept the risks, then that's great. Oh, because this doesn't exist. I'm going to define, to make this work, I'm just going to define a dummy function. So this is how you define a function. So I've got get sub get out a function. It's going to take an argument of account. It's just going to return. There we go. So it doesn't actually doesn't do much. It's returning a value.
Do you know when you return the account?
No, I'm just making the map work because I changed the map.
No.
So
what you're saying is, instead of saying bool, you can simply say account.
You're passing in JRebel.
Yeah. Okay. Yeah. That's yes. Sorry. Yes. I could do that. There we go. Professionals I'm dealing with here. There we go. I did say hacking Clojure. I think it is what it is. Okay, so now this one it's compiling. So when I'm evaluating it, I'm actually reading the code. So Clojure reads the code I've written, says okay, that's great. Then it tries to evaluate it, which involves compiling it, and then if that works, it injects it straight into the runtime environment. And that all happens instantaneously, so you don't have to wait for things to compile. So that's quite nice. So now if I want to get the blog post, I can still get the author from there. That's still going to work, except this time, return a vector result. Yeah. So do oops. So then we would need to.
So it's a vector, so now you need to use another function to access the elements of it. Right? Yeah,
exactly. And if I just wanted the first one, I could do simple things like I could just get the first, and then oops, missed that. I'm going all thumbs again. I'm not used to my keyboard because I use an external keyboard now. There we go.
Is that yours?
No, a nice external keyboard, I should say. So now I get the map of the first person, and I could also do another get, but there's also another technique you can do where you can where is it? If I can actually use the key itself. If a key is a type of keyword, it basically has the colon in front of it, then I can get name. So I can do name here. And so this keyword will act as a function on the map as an argument and pull out the first keyword, the first value that the value that the keyword points to in the map. There we go. So this will be another map with first and last name in there as well. Which is there, and then I could just do. Another one around there. First. There we go. I'll put this on the internet somewhere you can see, and they can all enjoy and giggle at my awesome Clojure code. And then we get that. So there are simpler ways to kind of construct it. You can also use, there's also a neat kind of thing down here. So we can use a keyword to get values out of a blog post. Sometimes if you've got like a little anonymous function, like this inline to the rest of the code, you're not calling an external function, you just want something inline, then this could be a nice, like simple, clear way to extract information from that. There's also this threading macro. So what this is doing is taking this blog post data structure, and in turn, it's going to pass it through functions. So this is the same as if we were calling. I didn't mean to do that. Yeah. So this is like if we're calling author, and then oops, oh, that's not right. Author, and then we had blog post here, and then we do the same thing for title as well. So this gets out the author, and then the next one we get out the title, and so we'd end up with we're changing now, haven't we?
Is that hyphen chevron? Is that the thing that changes the order which he writes off?
So this this dash chevron thing, whatever you want to call it, greater than yes. That's a threading macro. So there's a single head version and the double head version, but it basically allows you to write code that looks a bit more sequential in order.
So
rather than nested functions.
Function, parameter.
Yeah.
It's.
Is this called?
It's function and
I've got extra 5 minutes extra.
It's the other way around. It's parameters and functions.
Yeah. So we're passing. So these two things are functions, and we're going to pass this to author as an argument because it's going to go here. But then that whole value, the value of this whole expression, is then passed as an argument to title.
So the order is
this the same as calling get?
Yes, it is. It is the same as calling. It's the same as writing. Well, strictly, it's the same as writing title.
Blog post.
Author blog post. Yeah, or a blog post. There you go.
So
which is the same as doing gets.
It's function and parameters, whereas this has got parameters and function.
Yeah.
So the single one turns it down. What does you said it's two? You can do two placements.
That's just where it puts it. So if you wanted to have other arguments, if this keyword did take an argument in addition to the blog post, so there's some kind of format thing you wanted to do there as well. If you just use a single one, then blog post would be inserted before that in an argument, which might mean that the syntax of the function call is incorrect because the arguments are reversed. Yeah. So the argument order is important. So if you use a double-headed one, then it puts it onto the end. So you either have the start or the end. Okay. There are ways, but yeah, then it starts to get a little bit messy, and there are other ways to refactor it so it looks nicer.
This is like a pipeline thing.
It is like a pipeline, yes.
So it's like chaining and a pipeline.
Yes, indeed. Yeah. And again, it's exactly the same code. This is I'm going to use the M word. I'm going to use the macro word. Macros are good things to use. Again, we don't really write much macros in Clojure, except if we want to specifically extend the language, but it does allow us to extend the language without having to wait for the language authors themselves. So if you were ever frustrated with why aren't all these features in Java 11 yet, you could actually just have them and build them, and they would work with Java 8 because you just build them as extensions to the language as a library that you would use yourself. You don't have to get them included into the core of the language. Clojure itself does have a whole bunch of macros in there. So it's either written as functions or macros, and you can treat them just the same, more or less, in most situations. There's some limits on what you can, on functional composition you can get with macros, but mostly you can it's just a function that does some behavior, and you can just use it, use a macro just like that as well most of the time. What we do?
John, maybe can I ask a different question?
Certainly.
So, from a practical use point of view, where do we see Clojure being used currently? Like which type of applications are best suited for
Okay. While I figure out what code I'm going to, I'll answer the question of where Clojure is being really used and what it's really good for. As I try to think about what else I'm going to show you. I think we'll finish off this exercise. We'll finish off this session with doing. Let's leave that for now. Oh yeah, we'll do the Fibonacci sequence. I'll just say how would we solve the Fibonacci sequence? So that's what I'm going to do next, just after I explain where Clojure fits in, I think. So I think like Clojure is a general purpose language, so you can basically build anything you want with it, which isn't really helpful in answering your question specifically. But yeah, so any way you're using Java, you can use Clojure. But where does it excel? So one of the design things around Clojure was to make concurrent programming a lot easier. And if you've got immutable data structures, all your data is immutable. And if you've got fairly pure functions, then it's really easy to reason about your application, but also really easy to create code that is very highly threaded, so very concurrent, because you're not interfering. No thread is interfering with any other thread, because they've got their own information and their own self-contained functions, and they're just going to give results. So it's like doing when you do like map and reduce over large data sets. You don't have the sense of conflict, concurrency conflict, because you're breaking up the sets into each thread as its own copy that no other thread interferes with, and then it's really simple. So you're actually moving from concurrency more into parallelism, which makes your system so much simpler to use. Concurrency is not easy. There's no way to do concurrency easy except for not doing concurrency. That's the easiest way to do concurrency. And the easiest way to get the benefits of concurrency without doing concurrency is doing parallel systems. So that's why you get all the big data, AI, machine learning stuff, whether they're using Clojure or not, they're moving towards more mutable kind of data, but certainly doing things in parallel as well. And I think that's one of the big kind of selling points of Clojure in terms of why people are using it. Certainly in banks, financial institutions, pushing through vast amounts of data and not having to worry about like really complex, convoluted concurrency models and so on. Yeah, so that's a real win. But yeah, there's loads of different companies, from like doing simple websites to doing like complex financial stuff as well. So the world is your oyster when you're doing functional programming. Even doing some game programming and like creative arts as well, you can do that in Clojure as well.
Yeah. I think I saw someone say that Clojure doesn't have frameworks, and that's one of the benefits. Everything is just libraries, it's just functions and function composition. And there's no concept of a framework, which makes it a lot simpler.
Yeah, so there's so in Clojure there isn't really one framework to rule them all. There's no kind of Lord of the Rings kind of framework. There's no Spring kind of thing. There's no kind of big framework like J2E or Spring kind of thing. There's some people so we have lots of libraries, and we basically assemble libraries together. And some people will define templates that kind of bring libraries together as an example of how you would build an application with like the core libraries as well. If you've got libraries, you can easily swap them out. So there's quite a few libraries that do the similar kind of things, but in different ways. So it depends what you actually want to achieve. So you can be quite flexible. You can still build a website, but you can do it in a lot of different ways, which initially is kind of confusing when you join the community. But it's very easy to ask people's opinions, and they'll give you like 2 or 3 kind of options, and you choose the one that's best for you as well. So it gives you that flexibility, but it does make you think how you want to build the system. So it's a little bit more thinking time, but then you're actually thinking about what you actually need to build, and you don't have any extra stuff. You're not building something just because the framework says you have to do it that way. You're actually building something because it's the way you actually want to work. And it's suitable for your thing. So you can be a lot more tailored to how you build an application in that way. But most of the libraries are built on top of each other. So for example, if you're going to build a website, you start off with a simple Ring application, and what Ring does, the most important thing Ring does, it takes HTTP requests, which are horrible things, and makes them into a nice pretty map. Once you've got a map, you can do anything you want in Clojure, and everything is really simple, as we've seen. And then you can add on top of that something called Composure, which basically does all the routing for you and uses maps and so on. And everything just becomes data. Once you get everything into a nice Clojure data structure, then everything is just writing a function that does something with a data structure, and you're done. And so it breaks everything down into a very simple approach. Obviously, you've still got complex problems to solve, and you still need to figure out all the behavior and so on. And there are plenty of libraries out there that allow you to do that. But yeah, it does give an awful lot more flexibility in how you build things, and it also makes them quite light as well. You don't need a big framework to do things. You can get things done pretty quickly. So it is an advantage, although it is a bit to get used to and get accustomed to as you're building.
Is there anything which helps when you're accessing, let's say, these rather large data structures in terms of, let's say, accessing something which is 4 levels deep? How do you memorize or know all the names and all the fields?
Well, you don't need to, I mean, if you're, how do you work through like a big complicated data structure? It's one of the advantages of if it's more of a map-like format, then it's kind of almost self-describing, because you've got all these keys that are actually describing the things for you, and you can ask the map just to give you all the keys. And you can actually just iterate through the entire map in all the different levels to get all the different levels of keys and just bring it back as one big data structure. And that's the metadata view. So the map itself can give a metadata view of itself with all of the kind of things you could get from it. It's not showing you the values because you just want to see the structure. And that's very easy to do because you're just transforming one data structure into another, and that's what Clojure is really good. I mean, there's like basically 600 functions you can choose from that will help you do that just in the core language itself. Obviously, there's a challenge you don't have to learn all the 600. I mean, you probably learn about maybe, even though like a fairly advanced Clojure developer probably only uses about 100 of the functions, but it's using the right 100 functions. That is a tricky bit. So we've got about 7 minutes, well, you said 35, so I've been updated to 35, 12:35. 12:35. So if you've got 7 more minutes or 6 more minutes now,
yeah, we can do Fibonacci.
Then we do Fibonacci sequence.
Really impresses with something
I've already
really sexy.
Yeah, Fibonacci.
Fibonacci.
I haven't seen Fibonacci in Clojure.
I think Michael, you've seen everything before.
Oh, Michael's seen everything.
Yeah. So this is the.
Keeping that.
All right, let's crack on with it. So this is from a website called Clojure. It's nothing to do with mortgages. Everything to do with learning Clojure's functions. So it's given us 3 tests on the website. These are like our unit tests kind of things. And so we need to have 2. So we've got 2 functions. We've got this function and this function, and we have to make them equal to each other. So this quote here just means treat this list just as data. So rather than trying to evaluate one as a function call, it's just going to treat it as the value, integer value 1, and same thing for all of these. So I have to kind of say, okay, well, given the function and this argument, how is it the same? What is this missing part here that makes it the same, that generates this value in turn? So I need to generate a sequence of 3 for this one. I need to generate a sequence of 6 characters and 8 characters, and it's following the Fibonacci sequence.
Oh, so basically the first 3, first 6, or first 8 in the Fibonacci.
Yeah, exactly. Yeah.
Okay.
And so generating range is really easy. I mean, the first thing I thought was like, I can generate a range of things, but okay, that's just a sequential range of integer numbers, which is, and now I was thinking, well, maybe I can manipulate that by adding something together, but it doesn't quite. Fibonacci is not that easy to kind of just tweak like a sequential number. It's definitely seems to be the way I worked out was to, you're generating the sequence based on the previous numbers. And in this case, when we analyze the problem, we were actually all these, all the Fibonacci sequence starts with 1, 1. So we can actually start that and say, well, that's our starting point. A Fibonacci is going to be just returning a vector, like an array of a collection of 1 and 1. And if we call that, so
Can we do this with recursion?
We will get to that. I think will we get to that? I'll let you know if we don't. I'll mention that at the end if we don't.
We've
only got 5 minutes. Yeah. So if I put this, that's defining a function. So I can define a function with just the def here, and if I want to call it, so I do use fn if I'm just doing something in line. So if I'm calling something in line. And then this is, oops, I missed, there we go. And then I'm going to give it an argument, which is, if I give it an argument of, well, it doesn't matter what argument I give it in this case, because we're not actually testing for it. And then we do evaluate, and it's returning. So for a Fibonacci sequence of length 2, it works. For anything else, it doesn't. And same thing with here. So we put in here a check. So we're getting the size into the function. We're setting this let function is just defining a local name called fib to be our current Fibonacci sequence. So we're going to start with 1, 1, and then we're going to check to see if the size of fib is smaller than the size that was passed in as an argument. If it is, then we need to work out some kind of way to iterate around that. And if it's not, then we just return once the size is equal, pretty much. Then we'll just return what we've got. So we're going to go round and round and round until we get the right length. So that should satisfy all the tests once we get the iteration stuff done. And the iteration is quite clever. So we're using this idea. So we changed the let to a loop. So this is going to set up. This is kind of like the basic lowest level of kind of iteration you can do. It's the lowest level of abstraction in Clojure, doing a loop and recur. And to the question earlier, like this is going to do tail recursion, but through software. So it's not going. If we had a Fibonacci sequence of like 100,000 kind of thing, we wouldn't have to worry about our stack blowing up because it's reusing the memory each time we go around the loop. It's reusing the same memory to do the calculation. So what it's doing pretty much the same. So the loop is just replacing the let to kind of go around and call itself. So what recur is actually doing is calling back a loop, but with an updated set of arguments. So when we call loop the first time, we're setting fib to 1, 1. Then we're checking the size again, which we're still too small. So we're going to recur, and we're going to conj the current value of fib. And conj is basically creating a new collection. So we're going to create a new vector from the existing value of fib, which is a vector. So that's why it's going to be a vector, because fib is already a vector. And then we're going to add to that 1, 1 vector another value, and that value is the evaluation of this function, reduce plus fib. And all this is going to do is take the two values of fib and add them together.
Okay.
So that
can you add when you take one vector,
yeah,
and you add something to the end of it,
yeah,
does it copy the whole vector and you get one bigger, or does it just add to the end?
The first one. So when you take a vector, a collection, and you add something to it, it will create a new one with the original thing in, and then add the new value in. So you create.
As you calculate if you calculate 100 length Fibonacci sequence,
yes,
this will create 100 other unused vectors.
It will. So this will create 100 vectors, but because we're using loop and recur, each vector that we're creating is overwritten each time we go around the loop. So we're only actually using the space in memory for one vector, but we're doing that 100 times. Yeah. So it's there are more efficient ways to do this. This is just showing you how the basics work. And I've got no minutes left. I'll answer your question in a minute. I'll just finish this off. So this one works for up to 3 sides, because it'll add 1 and 1 together and return 1, 1, 2 as a result. However, it won't do any longer ones, because then we're still just adding 1 and 1 together. So what am I doing? So yeah, so here we're getting 1, 1, 2. So I need to extend this a little bit. And what I've done is, what did I do differently there?
It's the same, actually.
It is the
Why
same.
is it giving different results? Oh, because you put 6 and you put 3 there. If you would have put 6 on the previous
Oh,
one.
yeah. No, but if you actually look at the sequence is not correct. It's not. So it works. It generates a sequence, but not a correct sequence, because I'm just adding the wrong numbers together. Yeah. Exactly. Yeah.
It's
and
not Fibonacci, it's John Stevenson sequence.
Yeah, exactly. And so what I'm doing, so if I make a refinement just to the extra value that we're passing, that we're conjing onto the fib. So we're still conjing the initial value onto fib the first time. So this is still 1, 1. But this time we're actually and then this will go to 1, 1, 2. And then when we do this for the second time, we're going to take we're going to reverse the function. Reverse the data structure. So we'll have 2, 1, 1, and we're going to take the second value and the first value. So basically, instead of getting, let's go up to here. So we'll reverse these things, and we'll basically get the last and the second last. there's no second last function in Clojure. There is a last and there's a first and there's a second, but there's no second last. So this one,
Can't you just do last one?
there probably is better ways to do it, but what I've done here is just reversed it and got a second, which gives me the second last value. So I'm adding the second last value and the last value together each time, and each time we're adding a new value to the last. So therefore, we kind of always getting the last two values. So it's always going to generate.
Which is what Fibonacci is doing.
Yeah.
If you manually iterate through.
And then we get the score that works. Thank you very much. Come on. So I'm happy to stay here for a while and answer more questions. But if you're hungry, then I reckon you should go out to lunch as well. You had a question, Mr. Manning?
What I was going to ask is earlier you mentioned about how it's going to reuse by only picking up the bits that's different, right? Is that not happening with vectors? You know, like for example, you reassign.
Oh yeah.
That could be happening in vectors as well, right? Because the elements are
Incremental, kind of delta.
So when it creates a new data set, it just creates the pointers, and only the bits that are different, it creates a new value.
Yes, yes. So while you're doing when you create a new vector from an existing vector, then it's going to reuse whatever it needs to.
That's what I thought.
Yeah.
So it will probably create hundreds of those, but each one of them are efficiently used.
But it's creating them on top of each other, so it's actually not using it. Basically wipes out the intermediary vectors you're doing and only creates one, which was the last one you ever used, and then everything's gone. And if you have many of these, if you have kind of quite a few intermediary collections that you're creating, there's something called transducers, which will allow you to basically not create those as well. So transducers is like doing an iteration with multiple different functions. And so you can do this quite complex transformation, but it doesn't. It's much more efficient because it's not generating all these intermediary collections.
Basically, what you're saying is whenever the function gets kind of evaluated, then that becomes then for the next function that will become the vector. So that's why we are replacing all.
The middle ones become dead, so they get removed.
Yeah, exactly. Yeah. So it's much more. So you can make it really efficient if you need to. But again, this is pretty efficient as it is, and I only start doing that sort of stuff when you've got performance issues. It's one way to actually make streamline your Clojure code as well.
Thanks, John.
Okay.
Thank you,
Thank
John.
you very much. It is now lunchtime, so I'll remember to stop broadcasting, and hope everybody who watches this after the event found it enjoyable. Thank you very much. The next virtual study group is on Sunday, the 25th at 11 a.m. UK time. Thank you. Bye.
Cool. Make sure I don't miss the one tomorrow. You're going to be